Today we're going to go over the other two types of conic sections, hyperbolas and parabolas. So one more time for a quick overview, the first conic section that we looked at was a circle. And so a circle is formed by cutting a cone parallel to its base. And a circle is the set of all points that are equidistant from a fixed point called the center. An ellipse was what we looked at next, and that's formed by cutting the cone diagonally, but not through its base. And then we form an ellipse. Remember, ellipse was the sum of all points, the set of all points. The sum of the two distance from the two foci is always constant with the string all the way around as an ellipse. So we're going to look at today the other two shapes just as a bare overview. So you've done a lot of practice with circles and ellipses, and that's our focus for this year. But there's also the parabola. So it's a new way of thinking about a parabola. It's the slice of a cone, and it goes through the base of the cone. So there's your parabola shape. It's a slightly different slice than the hyperbola. Hyperbola has to be completely perpendicular to the base, so that if you put another cone on top, you would go directly through both of the cones. So the hyperbola, when you end up looking at it, if it's the two cones, it looks like it's this shape going away from each other. So it's like two parabolas going away from each other. So we're going to look at an overview of those shapes today, and then you've got 2 days to work on the review sheet. So for today, we're just going to kind of go through these problems together. So first, we're going to look at the definition of a hyperbola. So this time, it's a set of points such that the difference of whose distances from two fixed points is constant. That's just the opposite of an ellipse. An ellipse was the sum of the distances is constant. This time, the difference of those distances is constant. So here's the steps of how to graph a hyperbola. So the first thing is we are going to find the center of the hyperbola, and we're going to find the A and the B values. So in this format, whatever comes, because this is not the commutative property, subtraction goes in a specific order. A squared always comes first. A squared might be bigger or smaller than B squared, but A squared always comes first in the equation. And you're going to use A and B to represent the length from the center to the endpoint of the transverse and conjugate axis. So instead of calling it the major axis and the minor axis, because A could be shorter now than B, they don't use the word major anymore because we just use transverse. So the transverse axis is going to be horizontal because the A value was under X. So if X squared comes first, it's going to be horizontal, and so it will open in this direction. If Y squared comes first, it's going to have a vertical transverse axis, and your hyperbola is going to look like this, opening up and down. So this is a vertical transverse axis versus a horizontal transverse axis. Our A value is 4 because A squared is 16, and our B value is 5 because B squared, or square root of 25, is 5. There is a different Pythagorean identity, if you notice now. So the C value is now the longest value, and I don't have a pretty easy way to understand the identity for this one. So you're just going to have to, for this basic overview, believe me that C squared is equal to A squared plus B squared for the hyperbola. So 16 plus 25 would give me 41. So the square root of 41 is the C value. So the square root of 41, is 6.4 about. So let me show you what it looks like when you plot the graph. You're going to find the center. Our center is at 0, 0 because we haven't gone left or right with that H value or K value. So 0, 0, center. We're going to go horizontally 4 in either direction. 1, 2, 3, 4. 1, 2, 3, 4. We're going to go 5 vertically. 1, 2, 3, 4, 5. So if we were drawing an ellipse, 1, 2, 3, 4, 5, we would just draw the ellipse and we would be done. However, this is a hyperbola. So what you do is you draw in this box around those endpoints of your transverse and conjugate axis. This is called the transverse axis, and then this is called the conjugate axis. So you now draw in the diagonals of that box. These become the asymptotes of your hyperbola. Because this has a horizontal transverse axis, we want to start at these endpoints and go in this direction towards each of our asymptotes. And the final point that you want to plot is your focus. So the C value is still the distance from the center to the foci or focus. So from the center, 1, 2, 3, 4, 5, 6.4 units. And 1, 2, 3, 4, 5, 6.4 units. So these parabola shape or hyperbola shape open around each of the foci. So there's a lot of information on that graph. The only part that is physically the hyperbola itself is actually these two curves. Everything else on the graph is just a framework, right? So the endpoints of the major and minor axis, the asymptotes, and the foci, those are all just features on the graph. So the equations of these asymptotes are lines. This happens to go through 0, 0 and go up 1, 2, 3, 4, 5 and over 4. So they are lines with a slope of 5/4. So I can write it y equals plus or minus 5/4 x, just like y equals mx plus b, but the y-intercept is 0 this time. So now let's take a look at a hyperbola that is vertical. So the A value this time is 6 from the 36. The B value is 8 from the 64. And when I do 36 plus 64, I get 100. So that tells me that C by itself is just 10. So this time, my center is still at 0, 0. My A value is 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. My B value is 8. 8, 8. Now, instead of drawing in an ellipse, I'm going to draw in this rectangular framework. And then here's my asymptotes. All right, so this time my transverse axis is vertical. So this is a really wide hyperbola. Starts here.